Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's illustrate the limit of a polynomial function. In the previous videos, we're able to understand that direct substitution is not necessarily the limit of a given function. I mean, the direct substitution of the constant c, which is the value that our x approaches to in solving for the limit, is not necessarily equivalent to the limit of the function. But for this limit theorem here, the limit theorem for a polynomial function, direct substitution is already its limit. We can write the polynomial function in this manner. This is the general form. F of x is equal to a sub n, x to the power of n, plus a sub n minus 1 times x to the power of n minus 1. It's minus. You have plus a sub n minus 2, x to the power of n minus 2, plus dot dot dot, plus a sub 1 x to the power of 1, or simply x, plus your constant 0. This is an example of a polynomial function. We only have one variable x. The a's there are all constants, okay, and that we have the decreasing order of our exponents of x. You have n minus 1, n minus 2, until you have here the constant. The limit of this function, according to this theorem, as x approaches to c, is just equal to f of c, the direct substitution of the value of c on our given function. Let's illustrate this using a given example. Let's say our function here is 2x squared minus 4x plus 5. Okay, so if you have here the limit of our f of x as x approaches, let's say 2, this is just equal to the limit of the entire function 2x squared minus 4x plus 5 as x approaches to 2. This theorem tells us that we can just simply substitute this value here and here, and whatever be the result, that's the limit of this polynomial function. Direct substitution holds here. Of course, let's try to illustrate that using other limit theorems. Let's have here again the limit of the same function 2x squared minus 4x plus 5 as x approaches to 2. Let's apply the limit theorems before on addition and subtraction, or the sum and difference, as well as the product and the power, in illustrating the result of this using those previous theorems. So we can actually have it like this: the limit of just the first term as x approaches to 2 minus the limit of the second term as x approaches to the same constant 2 plus the limit of the constant 5 as x approaches to 2. So we have here three different functions now, and we have that in a limit theorem for sum and difference, that the limit of this entire is just equal to the limit of the independent or individual functions using the operations stated. So we are going to apply the first. So this has product and power. So we have here 2. We have your constant. You can separate that, right? You will have that. You can write it in this manner. We have using the limit theorems before. Okay, so using the previous limit theorems, we can separate that product, the limit of 2 as x approaches to 2 times the limit of x squared as x approaches to 2. This is the limit theorem of the product, minus, same thing here, the limit of 4 as x approaches to 2. Okay, this is why these theorems are very long to write, as x approaches to 2, of course, plus still the limit of 5 as x approaches to 2. This is very long using the previous limit theorems. So we have here, of course, that's a square. Let's just apply immediately. The limit of a constant is 2. The limit of the constant is the constant itself. You have the limit of this is actually the square of 2 minus the limit of a constant is 4. The limit of an identity is the value of c here, which is 2, and you have the limit of a constant, again 5, is equal to the constant itself. So using the previous limit theorems, you will have here 2 squared is 4 times 2, that's 8, minus 4 times 2 is 8 plus 5, and you have here the result is 5. This is by using the other limit theorems. Of course, if you're going to use that, then it's very lengthy. But this limit theorem for polynomial function allows us, going back here, to immediately substitute using these concepts into 1. So you have 2 squared minus 4 times 2 plus 5, which is similar to this. Okay? So it's a little bit shorter because of this limit theorem for polynomial function, which will give us 8 minus 8 plus 5, the same result of 5. As you can see, this limit theorem for polynomial function is shorter because you're already accepting here the direct substitution of the constant c on our given function, which is equal to the limit itself. But we could also use the previous limit theorems if we would like to, but it's just a very lengthier one. So this is how we illustrate the idea of the limit for a polynomial function. Simply substitute immediately, no need for other limit theorems. So what are you waiting for? Subscribe now!